Welcome to this lesson on angle properties of a circle. Before we dive into the main lesson, here is a quick review of some basic circle terminology. In this circle, point O is the center and the curved outer edge is called the circumference. Point A is on the circumference. The line segment OA is called the radius. The measure of the radius is constant from any point on the circumference. Therefore, a center point and a measure of the radius is all we need to define a circle. B is another point on the circumference. This curved edge between A and B is called an arc. An arc is a part of the circumference. The shape between the arc AB and these two radii is called a sector, pretty much like a slice of a pizza. Quite yummy, but let us not get distracted. Note that the plural for radius is radii. 1 radius, 2 radii, and so on. While this small pizza slice is quite easy to notice, the remainder of the circle is also a sector. The smaller one is a minor sector, and the larger one is called a major sector if it is bigger than half the circle. The minor sector is bounded by a minor arc and these two radii, while the major sector is bounded by a major arc and the same two radii. If the two radii line up to make a diameter, the two sectors are equal and each is known as a semicircle. To recap, two radii divide the circle into two sectors. But there is another way in which a circle can be divided using a chord. A chord is a line segment joining any 2 points on the circumference. So if we draw a chord from A to B, the chord divides the circle into 2 segments. The top one is a minor segment and the remainder of the circle is a major segment. The diameter is a special case of a chord which must pass through the center of the circle. Diameter is twice as long as the radius and it divides the circle into 2 equal segments. Let us now dive into the main lesson. The angle properties of a circle are summarized in a number of statements called theorems. We shall visually demonstrate the ones most relevant to high school maths, one theorem at a time. Let us get back to the arc AB. We shall now subtend an angle AOB at the center of the circle from the arc AB. We shall also subtend an angle ACB at the circumference, but from the same arc AB. Let us now measure the angle AOB at the center and also measure the angle ACB at the circumference. Take a closer look at the measure of the two angles. Are they equal? Quite obviously not. We can observe that 1. The measure of both angles depends on the size of the arc. 2. The measure of the angle ACB, the one at the circumference, is the same even as the point C moves anywhere on the circumference, as long as the arc length is not changing. 3. The angle at the center is always twice the size of the angle at the circumference. This simple relationship is important. It is a visual demonstration of the theorem that The angle at the center of a circle is twice the angle at the circumference subtended by the same arc. This is our first theorem. Please take note. Let us now use this theorem to solve a few examples of examination type questions. Example 1. This question requires you to find the value of the angle labeled x. Would you like to pause the video and attempt to solve it yourself? I hope you did. Let us now continue. By tracing the legs of each marked angle, we note that both angles are subtended by this arc. Quite clearly, x is the angle at the center and should be twice the angle at the circumference. So we simply double 46 degrees to find that x is 92 degrees. Example 2. Again, you are required to calculate the angle marked x and to give a reason for your answer. You might want to pause the video and try solving it on your own. This diagram requires a very careful look to see the second leg of each marked angle. This is because two legs are overlapping along the diameter. But when we trace the legs of each angle, it becomes clear that both angles are formed by this arc. Once that is established, we note that the angle at the center is 118 degrees and x is the angle at the circumference. So we need to divide 118 degrees by 2 to give us x is 59 degrees. Reason: angle at the circumference is half the angle at the center. Example 3. Pause the video and take a few minutes to study and attempt this question. Then continue on to the solution. First, we notice this arc and the two angles formed by it. If we knew the angle at the center, we would just divide it by 2 to get x. But the question becomes, how do we find the angle at the center? The key lies in recognizing this isosceles triangle. Because these two are radii, they are equal. Therefore, the angles opposite each radius are both equal to 43 degrees. So now the angle at the center is 94 degrees because the angles in a triangle must add up to 180 degrees. So now x will be 94 degrees divided by 2. X is 47 degrees. The annotations on the diagram will help you construct an explanation of your working. Watch part 2 of this video to learn more angle properties of a circle. If you found this video helpful, please share it with a friend. To get notified on new videos like this, subscribe and hit the notification bell now.